In this lesson, we are going to be looking at what we call linear programming problems. They are basically systems of inequalities that you make your equations for, and then go ahead and graph them and look at possible solutions. So, lots of steps to these. This first problem, we're looking at Yvette Bryn, who has her receptionist schedule some appointments. She allots 50 minutes for surgery. So let's just call surgery x, okay? You have to define your variables. So x is surgery. And then 30 minutes for an office visit is your other variable, your other thing you're talking about in this problem. So y, let's call office visits. Okay? So 50 minutes for every surgery, so that'll be like 50x. 30 minutes for every office visit, so that would be 30y. And she has a total, if you read, of 6 hours to work with. So you kind of have one thing going on, which is time in this case. Okay, so 50 minutes for surgery, 30 minutes for office visit, 6 hours or 360 minutes total to work with. Then the other thing that's going on is she cannot do any more than 6 surgeries in a day. And that's sort of a separate problem. Okay, but here we go. You're going to make 2 inequalities whenever you do this. Actually, you're going to make 4. Okay, and here's what everybody should be able to do this. One inequality you should have is x is greater than or equal to 0 and y is greater than or equal to 0. Those 2 will happen every single time. The reason is you can't have negative numbers of surgery and you can't have negative numbers of office visits. And no matter what real life situation you're talking about, you can't have negative of anything. So you should always have those 2 inequalities as part of your problem every single time. Okay? That is why when we do the graph, we only worry about the upper right-hand corner where everything is positive. Okay? So I'm actually going to label my axes right now. Remember that our x, this is our x-axis, was surgery, and our y was office visits. Okay, and I've already labeled it for you, so that's good. All right, then going back to our problem here, we need to make one equation that deals with time. So that one equation that deals with time will look something like this. 50 minutes for every surgery, so 50x, plus 30 minutes for every office visit, and she has no more than 6 hours to work with. So that total amount of time there, the 50x plus the 30y, has to be less than or equal to 360. And you're going to use the 360 minutes versus the 6 hours so that all of your units of time are the same. Okay. Then the other piece that you need to worry about in this case is your x has to be, or the number of surgeries. It says she can't do any more than 6 surgeries in a day. So I'm going to move this down here. So that means if she can't do any more than 6 surgeries in a day, surgeries are x, so x has to be less than or equal to 6. Okay? These 2 equations over here, I'm not going to worry about you graphing. I don't expect you to graph them. I do expect you to have them written. I do not expect you to graph them. I'm only going to give you the upper right-hand quadrant, which is basically saying that it takes care of both of those inequalities, okay? But let's graph this one right here. Okay, if it's x is less than or equal to 6, that means x is held constant at 6, so it's a vertical line. It needs to be a solid vertical line since it is underlined, and it's less than, so I would shade to the left. Okay, then this equation, in order to graph it right here, needs to first of all be in y equals mx plus b, so I will subtract 50x. And I will have 30y is less than or equal to negative 50x plus 360. Divide by 30 all the way across. And I will have y is less than or equal to negative 50 over 30 reduces to negative 5/3 x. And then 360 divided by 30 is 12. Okay, so now this is the equation I want to graph. So it has a y-intercept of 12, and it has a slope of negative 5/3. So that means I'm going to go down 5, and right 3. Down 5 and right 3. Down 5, right 3. So it'll look something like this. It is underlined, so I will connect it with a solid line, and that's probably a little crooked, but there you go. And it is less than, so I will shade underneath that line. Now, again, your solution to this problem is really the spot where you see both colors. So in this case, the spot where I see both colors, I will highlight here in a different color for you. I want you to darken that in a lot, but here's the spot where you see both colors. Okay, so you go ahead and darken those in. All right, in the next problem, we are talking about Clara. And Clara makes $10 an hour teaching piano. I have to just change this here. She makes $10 an hour teaching piano and $12 an hour teaching guitar. Okay, so we've got two things going on, piano and guitar. And by the way, she can never teach negative number of hours of piano, and never can she teach a negative number of guitar lessons. So you'll have those two equations in there. But let's designate, let's say that X is piano and Y is guitar. Okay, she can't work more than 15 hours per week. Okay, so her total number of hours, and I should write this. X is hours teaching piano, and Y is actually hours teaching guitar. Okay? So when she adds her hours that she teaches piano and her hours that she teaches guitar, she can't have more than 15 hours a week. Okay? So when you do that equation, that will look like X plus Y has to be less than or equal to 15. Okay, so that's one equation I expect you to have. The other one is this. X has to be greater than or equal to 0. Y has to be greater than or equal to 0. She cannot teach negative numbers of hours of piano, and she can't have negative numbers of hours teaching guitar. Okay? Then if we go back to our problem here, so we've got one that just deals with how many hours she can do, which is 15. And we need another equation that deals with how much money she can make. Okay? And she can make $12 teaching piano. I'm going to kind of do this so that it doesn't get mixed in there. She can do $12 teaching piano, which is X, plus, sorry, $10 teaching piano. And $12 teaching guitar. And she wants to make at least $120 in a week. Okay? So there's your equations that you need. Now, the X is greater than 0, the Y is greater than 0. I don't need you to graph. That just puts things in the upper right-hand quadrant, which that's all I have given you, so you don't need to worry about it, okay? But these other two equations you do need to graph, so we're going to get this one into y equals mx plus b, and I'm going to just do this. Okay, I'm going to get it into y equals mx plus b, so I will subtract the x over, and I'll have y is less than or equal to negative x plus 15. So that means that it crosses the x-axis at 15. It has a slope of negative 1 over 1. I know things are not marked in increments of 1 here, but since your x and your y axis are scaled the same, you can still think about it as one box and one box. So I can still go one down, one to the right, one down, one to the right. So that would look like that. It is a solid line because it's underlined, and I would need to shade underneath it because it's less than. Okay. Then my other equation is this one, but it is not in y equals mx plus b yet, so I will subtract 10x so that I have 12y is greater than or equal to negative 10x plus 120. Divide by 12. And I'll have y is greater than or equal to negative 10 twelfths reduces to negative 5 sixths, and 120 over 12 is 10. Okay, so I want to graph that one. It crosses the y-axis at 10. It has a slope of negative 5/6. So down 5 and right 6, or you could go, yeah, down 5 and right 6. So the problem on this one is that it kind of runs off the graph, but down 5, 1, 2, 3, 4, 5, and right 6. 1, 2, 3, 4, 5, 6. It would connect right about there if I were to do it. And it would look something like that. This one is greater than, so I would need to shade above it. Okay. I really don't care about anything down here. It's not pertinent to the problem. But I do want to highlight the solution set, which is really where you see both sets of answers. And I see both sets of answers in this area in here is all. Okay? So I want you to focus on that. All right, a couple more. The area of a parking lot is 600 square meters. A car requires 10 meters and a bus requires 30 square meters. The lot can handle 60 vehicles total. Okay, so we have two things going on. We have X, let's see, which is cars, and we have Y, which is the bus. Okay, so again, can't have a negative number of cars, can't have a negative number of buses. So I expect you to have that those two inequalities there. All right, 600 square meters total. Okay, so a car, which is my X, is 10 square meters. And a bus, which is my Y, is 30 square meters. And when I add the square meters of the buses and the cars together, I can't use any more up than the parking lot allows, which is 600 square meters. Then in my other equation, I just have cars and buses, and I can only have 60 vehicles parked. So it has to be less than or equal to 60. My cars and my buses have to be less than or equal to 60. All right, let's get these into y equals mx plus b form. So here's your first equation that I would expect you to have written. And I will subtract 10x, and I'll have 30y is less than or equal to negative 10x plus 600. Divide by 30. And y is less than or equal to negative 1/3, that reduces 2. And then 600 divided by 30 is 20. So if I go ahead and graph that one, it crosses the y-axis at 20 and has a slope of negative 1/3. Again, I don't have things marked in increments of 1s or 3s, but since my x and y axes are scaled evenly, I can just go down one box, right 3. Down 1, right 3. So it would look like that. I need to connect them with a solid line because it's underlined, and I need to shade under it because it is less than. Okay, and then my other equation, if I subtract x, I'll have y is less than or equal to negative x plus 60. So that one crosses the x-axis at 60, or y-axis at 60, I'm sorry, and has a slope of negative 1. So down 1, right 1. I would also connect that with a solid line, and I would shade underneath it. Okay. And again, your solution set is really and truly only the places where you see both colors. And really, I didn't even need that blue equation because the red equation took care of it here. So that's all I need to worry about in this particular problem. And our last one. Farmer Ava wants to ensure a growing season of sufficient length for her crops. She has 15 days left to plant her corn and her soybeans. So I have two things going on. Let's call X corn and let's call Y soybeans. All right, she can plant corn at 250 acres. And by the way, she can't have negative corn and she can't have negative soybeans. So I need those two on there. She can plant corn at 250 acres per day. So 250 acres of corn, which is X, plus 200 acres per day of soybeans, so 200Y. And she has 3,600 available, so the corn and the soybeans put together have to be less than 3,600 acres. Okay, so there's that equation. Then the other one would be that she has 15 days left to work with. So between her corn and her soybeans, she can't use any more than 15 days. So you need that equation as well. Okay, so here we go. I will subtract my x. And I have 200y is less than or equal to negative 250x plus 3,600. Divide by 200. Y is less than or equal to negative 250 divided by 20 reduces to negative 5/4. 3,600 divided by 200 reduces to 18. Okay, so I'll go ahead and graph that one first. So that one crosses the y-axis at 18, has a slope of negative 5/4. So down 5 and right 4. Down 5, right 4. So it should connect like that. It is underlined, so I would make it connect with a solid line. And I would shade underneath because it is less than. Okay, and then the other one, I subtract x. Y is less than or equal to negative x plus 15. So this one crosses the x-axis or the y-axis at 15, has a slope of negative 1. So down one box, right one box, down one, right one, down one, right one. Would look something like this. Okay. So, and it also is shaded underneath. And so the spot where I see both lines, and this is a little hard to see maybe when you do this by hand and you get a little sloppy, but it's actually underneath here and then the blue. Okay. And that should do it.